So today we are going to talk about stoichiometry. Stoichiometry. So all stoichiometry is, even though it's a long and weird looking word, it's the calculation. So calculation of quantities in chemical reactions. I'll just write reactions in reactions. So when we talk about stoichiometry, we talk about the relationship between reactants and products. So reactants are the beginning of the stuff at the beginning of a reaction. The products are the stuff at the end of the reaction. So when we talk about stoichiometry, we're just talking about stuff at the beginning, or the reactants, and the stuff at the end, or the products, and how they relate to each other. So let's look back at our old hot dog example, our hot dog reaction we talked about a little while ago. So if we have hot dogs, hot dog weenies, so we have hot dog weenies here, plus hot dog buns, those yield hot dogs. So in one package, of weenies, we have, if you see this one row, there's 5, so there's 2 rows in one package, so that's 10 weenies. So we could write that as something like W10, subscript meaning there's 2 individual weenies in the package. Plus our hot dogs, or our buns, I'm sorry, there's 4 on one row, there's 2 rows, so there's 8. So we could do B8, because there's 8 in one package, so it has a subscript of 8. And that yields the combination of WB. 1 weenie and 1 bun for our hot dog. So first off, let's balance the equation. So keeping track of both sides, we have W, we have B. Over here at the reactants, we have 10 W and 8B. Over here with products, we have 1 W and 1B. So we have to figure out a way to make everything equal on both sides. Same amount of W's on left and the right side. Same for the B. Left and right side the same. So, first off, we need to figure out how to make the W's and the B's equal on this side, because they're always going to be equal on this side because they're stuck together. So, how can we find a number that's a multiple of 10 that's also a multiple of 8? So if we multiplied 8 by 5, we would get 40. So if we put a coefficient right here for 5, that would multiply 8 by 5 over here, and we would get 40. So cross that out. Now we have 40. And now it's easy to get 40 with 10, so all we do is multiply by 4. So we have a coefficient of 4 right here, so times 4. And now we have 40 on this side. So now it's super easy just to put a 40 as a coefficient over here in front of WB. And that gives us 40W and 40B. So now our balanced equation is 4W10 plus 5B8 yields 40 WB. So basically, we have this hot dog and bun reaction. And to make 40 hot dogs, we need 4 packages of weenies and 5 packages of buns. Another way of saying this is in our weenie bun reaction. For every 4 packages of weenies, we have 40 hot dogs. We could also say for every 4 weenie packages, or we have 4 weenie packages per 40 hot dogs. We'll just say HD, hot dogs, or weenie bun combinations. Another way to write that, if you remember miles per hour, another way to write miles per hour, let's get that in the screen. Another way to write miles per hour would be miles divided by hours, right? So, if we have 4 weenie packages per 40 hot dogs, we could write that as 4, we'll just say packages, per 40 hot dogs HD. Same for our buns. So we have 5 bun packages per 40 weenie bun combinations, or 40 hot dogs. So we could write that as 5 bun packages per 40 hot dogs. Or we could write it just like we have right over here. We could write 5 bun packages divided by, or per 40 hot dogs. So right here we have 4 over 40 and 5 over 40. So these are called our mole ratios. So mole ratios. So these fractions that we have, 4 over 40 and 5 over 40, they're called mole ratios. And mole ratios are extremely important and useful when we're trying to find out quantities that will react in a chemical reaction. Very important in industry and just in chemistry in general.